Okay, this is the explanation of exponential modeling, which is, I don't know, I guess a third packet in exponentials. All right, so first thing to notice, exponential functions model quantities that grow by a constant percentage every period, as opposed to linear functions that model an amount that models a quantity that changes by a constant amount. So in all these problems, you'll be reading about a quantity that changes by a certain percentage each period, as opposed to when you did linear functions back in Algebra 1, you know, it might be bank account earns $50 every month. The $50 is a constant amount, it's not a percentage. Okay, so we are going to be talking about how to interpret this equation, the standard form y equals a times b to the nx. The whole crux of this part of the unit is to be able to look at an equation and figure out a story that goes with it, or to read a story and translate that into an equation. Okay, so in that equation, A is the initial amount. B is called the growth factor. It's related to the rate that the quantity is changing. And then this number up here in the exponent, n, I'm going to call that the how often number. It's going to play a role in how often we're earning the interest rate that we are. So I've got 3 examples down here at the bottom page. We are going to write an equation for all 3. So the first thing I'm going to do is go through and try to find the initial amount for each one. So in example 1, an account starts with $800. $800, that's the initial amount. So that's A in this equation. Number 2, a population starts at 6,700. Yep, there it is. That's the initial amount. And there's A. Radioactive element starts at 200 grams. All right, there we go. Easy enough. So figuring out A from description is pretty easy. Next, we need to figure out B, the growth factor. We're going to do that by looking for the percent change in the problem. So in the first example, we're earning 14% interest. So our growth factor is going to be 1 plus 0.14. All right. The reason there's a 1 in there is that at the end of the year, we have all of the money that we had at the beginning of the year, so that's 100% of what we had, plus 14% more. So at the end of the year, we have 1.14 times as much as we did when we started. If we just put 0.14 in the parentheses, that would mean that we would have much less than what we started with at the beginning of the year, and that's not how the bank account works. You get to keep everything you started with, plus you get some more. So then in number 2, the growth factor, I see the 7% percent change in the problem. So the growth factor is going to be 1.07. So again, at the end of whatever period we're going to be looking at, we have 100% of what we started with plus 7% more. In the third one, the rate is negative. We're losing 30%. So the growth factor is actually going to be 1 minus 0.3. Which is going to be 0.7. Okay, now we want to look at the exponent. So we're going to be looking at how often we are earning this return. So in problem 1, we earn this return each year. So n, by default, means yearly. So in this case, in the first example, n equals 1. So in the numerator, you're just going to have to the x. So the final equation for the first example is 800 times 1.14 to the x. Start with 800. I get 14% interest per year, once per year. In the second one, a population starts at 6,700 and grows by 7% once every 5 years. So here, if it's once every 5 years, n is going to be 1/5. Once out of 5. So once out of every 5 years, you get 7%. So in the exponent, instead of just x, we're going to have x over 5. N was 1/5 times x is x over 5. So when I look at this, I start at 6,700. I get 7% extra once every 5 years. In number 3, I lose 30%, 8 times per year. So here n is going to equal 8. So I'm losing 30% 8 times a year. So here in the exponent, I'm going to have 8 times x. Okay, so there are a bunch of questions on the test that are like that, where you have a description and you have to write an equation for it. Also on the test, hang on one second. Okay, so also on the test, you're going to have to convert the equations you write into standard form, which is basically, so in standard form, n equals 1. So that in standard form, you can see what the annual change is. So in the previous examples from the last page, the first example was already in a standard form. We could see in the equation what the return was every year. It was 14% per year. And we knew that because the x was by itself. So on the test and in these examples, we need to get the exponent x by itself. And we're going to do that using exponent rules. So here, and when I'm looking at equation 2, I know that every 5 years I get an extra 7%, but the question is, how much do I get per year, not per 5 years? So to figure that out, we're going to take the 1.07, the x over 5, and then using exponent rules, I can do this. Okay, these two things are equal because remember, when you have an exponent raised to a power, you multiply them. I just use that rule in reverse. So 1/5 times x would give me back x over 5. So these two amounts are identical. And then I'm going to take my calculator and I'm going to do 1.07 raised to the 1/5. And that tells you, when you do that, you get 1.01362. Right? So this means that earning 7% every 5 years is identical to earning, so this growth factor is identical to earning 1.36% per year. So earning 7% every 5 years is the same growth as earning 1.36% annually. In equation 3, to get the annual growth, so remember from the example, I'm losing 30% of the mass 8 times per year, so how much am I losing in 1 year total? So we're going to use the same exponent rule. Right? 0.7 to the 8x is the same as 0.7 to the 8th to the x. And I'm going to do 0.7 to the 8th in my calculator again. You get 0.057648 to the x. So remember, the growth factor, the thing that's in the parentheses, always tells you how much you have at the end of the year or at the end of the period. This tells me that at the end of the year I only have 5.7648% of what I started with. So I actually lost So losing 30% of your quantity 8 times per year means that at the end of the year, you will lose in total 94.24% of what you started with. Okay, so sometimes you're going to see situations, word descriptions where you have to write the equation, and you're going to see this word continuous in it. Continuous. That should be a huge flag for you. Anytime you see a problem that has the word continuous growth, it grows at 5% continuously, or it decays at 11% continuously. The growth factor you're going to use is this number E right here. E is a constant like pi. It stands for an amount that's about equal to 2.718. So for continuous growth, we can look at this first example here. The initial amount works the same, so our initial amount is 400. But now, because I see the word continuously right here, I'm going to use a base of E. And when you use a base of E, you just put the percentage straight into the exponent, like that. So you don't have to worry about converting the percentage rate into a growth factor. In the previous problems, if we were earning 14% interest per year, we had to do 1 plus that number. The E already takes care of that. It's just the percent goes straight into the exponent. For example 2 down here, a population of 23,000 shrinks by 18% continuously. Again, initial amount is 23,000. I see the word continuously, so I know that I'm going to use a base of E. So here with continuous decay, if it's shrinking, you just put a negative sign in the exponent, and then you make it 18%, 0.18. So in some ways, when you see the word continuously, it's actually easier to write the equation. You just put E, and then you translate the percentage change directly into the exponent. Okay, so the problems on the other type of problems on the test you'll see is where you're given an equation and you have to tell a story. So here, my initial amount is 123. So maybe I start with $123. And then I'm earning 2.3% interest. But if you look at the exponent, it's only happening every 10 years. Right, so the T over 10 means 1 in 10 years. I earn 2.3%, so this is not growing very quickly. Now, what you need to notice, and what the biggest mistake people make here, is that the instructions tell you have to say the annual growth rate. So from looking at this, I know it's 2.3% every 10 years, but we're going to have to do that process I showed you above, where we're going to take the growth factor and make it so that the exponent is by itself. So you're going to do 1.023 raised to the 1/10. When you do that, you get a growth factor of 1.002277 to the T. That means that the annual growth of this account, so not once every 10 years, but each year you're getting 0.2277% interest. So this is kind of a bad account. Second problem, I'm going to start with $45. This account is even worse than the one before because we're actually losing money. Here, I'm losing 20%. I'm retaining 80% 3 times per year. Start with $45 and lose 20% 3 times per year. Again, we need to change to an annual growth rate, so we're going to do 0.8 cubed. That's 0.512. So over the course of the year, I'm actually losing 48.8% per year. That's not good. The next problem. I start off with 17 rabbits. And the population is growing continuously. I know it's continuously because I see the E. At 9.8%. To figure out what the growth rate is when you have E, your calculator has an E button, so I'm just going to do E to the 0.098. It equals 1.10296. So what that means is that annually it's growing by 10.29%. The last one, again, I'm starting with 172 bacteria, and the population size is decaying continuously by 17%. So to get the actual growth rate, so you can see the annual change, not the continuous change, you do e to the negative 0.17 in your calculator. And that equals 0.84366, which means that every year you are losing 15.63% 3% each year.